Hello everybody, today we're going to explore capillary action. This is when liquids flow upward through a narrow space. To do this, we're going to perform a few experiments. First experiment, I'm going to need a little plate, add some water, add a little bit of dye to our water, and then we're going to need to construct a little setup, right? What we're going to do is to take two acrylic plates, add a paper clip, add the other plate, and then bind them together. Just like this. Then we're going to take our little setup and put it in water. This experiment is going to take a little bit of time for us to see the capillary action. So in the meantime, we're actually going to do a different experiment. We're going to take a coffee filter, fold it in half, like this. Fold it in half again, like that. And then we're going to take our favorite expo markers, right? We're going to go ahead and draw lines across our filter. Just like that. Then we add a little bit of water to our other plate. And then we'll take the tip of our filter and put it in the water. You can start seeing that the water's going upward on the filter. Cool, right? So what's really going on here? The ink pigments dissolve in the water because it's water soluble. As the water travels up the paper by capillary action, it carries the pigment along with it. How fast each pigment travels depends on the size of the pigment molecule and how strongly the pigment is attracted to the paper. The spaces between the fibers and the paper act as capillary tubes. This technique is called chromatography and was originally used for separating pigments that made up plant dyes. There are many different types of chromatography, and all of them, a liquid, like the water that we're using, or a gas, flows through a stationary substance, like the paper. Chromatography can determine the chemical makeup of a flavor or scent, the components of pollutants, and can separate blood proteins. Look how cool! We still have a little bit of time before the last experiment's ready, so we'll do one last one. Add a little dye to our water. I'm going to take a little tiny straw. And we're going to put the tip of it in the water. Right. Pull it out and see. It went up the tube. So, how is any of this nano? When things get small, they can behave in surprising ways. Different physical forces dominate when things get very small. For example, gravity is very important to us on the microscale, which is hardly noticeable at the nanoscale. Currently, paper diagnostics use microtechnology to test small amounts of urine or blood, but nanoscale features may make them even more useful and accurate. So let's go back to our final experiment. Remove the clip, and you can see on the sides the water rose. Awesome, right? Thank you for watching this video. This presentation has been brought to you by the Center for Materials Research at Norfolk State University and the Children's Museum of Virginia.